The last 3 tests we've taken, solving systems by graphing, by substitution, by elimination, I promised you that all of your answers were going to be a nice, neat, ordered pair. And I even said all of them will be whole numbers, except for that one oops, right? So every one of the problems you solved of your systems of equations worked out to actually meet at a point. So special cases means every now and then something weird's going to happen. So for any of your answers for tests 17, 18, 19, and 20, whatever we've taken, have you ever had a no solution or an infinite many? That hasn't happened yet, okay? So what we're doing next is talking about what special cases mean and what do they look like on a graph and what do they look like in equation form. So let's talk about special case number 1. Special case number 1 gives you an equation like this. 3x plus 2y equals 10. And then 3x plus 2y equals 2. Here's the awesome part about when I teach special cases. You know how to graph, you know how to solve by eliminating, and you know how to solve by substitution. So you can pick whichever way you like best right here. Are you going to graph those though? No, because if you do, you got to solve each of them for y. Looks like a pain in the butt, might not go evenly. Are you going to even use substitution? Probably not, because then I still got to solve one of them. This is set up beautifully for what? Elimination, okay? It's almost ready for elimination, okay? Let's just say I want to cancel out the x's. Well, a positive 3x and a positive 3x don't cancel. So let's just subtract this whole equation from that first. And I'm going to change the sign of this, which also changes the sign of this, and also changes the sign of this. So I have kind of a new and improved equation here. Now I'm ready to add and eliminate like we just learned, except what happens. When I go to cancel the 3x with the negative 3x, that's what we expected. That's why we did it. But what else happens, Evan?
You cancel out both y.
Yeah, oops. Usually when I cancel one variable out with elimination, the others at least add up. And then I divide and I have an answer. So what's left on this left-hand side of this equation? Nothing. A big old 0. Not 0x plus 0y, 0. Let's finish. What is 10 plus negative 2? 8. Do you remember what we did with this? This was when we did with one equation. When your variable ended up canceling out, okay, so this is what I want you to write. For systems, when both of your variables cancel, we got a special case on our hands. Only one of 2 things will happen every time, I promise you. The resulting statement that you're looking at is either going to be true or false. And last time I checked, 0 does not equal 8. 0 equals 0 and 8 equals 8. So when both of my variables were eliminated, okay, I ended up with a false statement, which means what? Do you remember? If I'm saying, what's the solution? Where do these 2 lines meet? A false statement means they don't meet anywhere. So when something like this happens and your variables cancel, you're not going to tell me it meets at 3, 2 or 1, 5. It doesn't meet anywhere. You're going to write the words no solution. Okay? And that is option number 1 in terms of how to solve this. Is use elimination or substitution, right? I want to know how this would look on a graph. The minute I get no solution in a system of equations, what can you 100% tell me about what these lines would look like if they were graphed? They would be parallel to each other. And what do you know about parallel lines and their slopes? So remind me, parallel lines have what? Same slopes? But what? Good. Different y-intercepts, right? So let's just confirm that. So I know for a fact parallel lines have the same slopes, but they have different y-intercepts. So could I just real quick kind of solve each of these for y, since you are masters of doing that by now. You've done it enough. Let's take this one. 3x plus 2y equals 10. 3x plus 2y equals 2. And I'm just going to kind of cruise through this pretty quickly. I'm solving for y because I want to see what it looks like in terms of slope. Oops, I didn't do that yet. I want to see what it looks like in terms of slope and y-intercept. You don't have to show all this work. I know that you guys know how to do this now. Plus 5. So what is my slope? Negative 3/2. What is my y-intercept? 5. Okay, let's do the same thing over here. It's going to start the same way. Get my y. 2y is equal to negative 3x plus 2 this time instead of 10, which means when I go to divide that, I'm still going to get my negative 3/2, but my y-intercept is going to be what? 1. So what is my slope here? Negative 3/2. What is my y-intercept? 1. Do they have the same slope, different y-intercept? Yes. Does this confirm that they are parallel and they have no solution? Yes. So guess what we're going to call this? Option 2. So today when I give you problems to practice, I'm going to ask you, how many solutions does this system have? Don't worry about giving me the answer. I just want to know. Does it have no solution? Does it have one solution? Does it have no solutions? So you can either solve it to see if you get a true or false statement, or you can solve them both for y and compare their slopes and y-intercepts. Options are always nice, right? When you go home, you want to do the laundry or the dishes today, you pick. So you get to pick. Solve it with an actual method or solve them both for y. If you know that solving for y is not your strong suit and every test we've taken you've always solved one for y wrong, you might want to stay away from that method. You might want to stick to elimination or substitution. Are you good with parallel lines? So no solution means the lines are parallel and they'll have the same slope, different y-intercept. That's what it looks like both ways. Are you good with special case number 1? Okay, good. So we're going to move on to special case number 2, which I think you already know what it is. You might even already know what it looks like because we've seen them before. So let's take a look at this equation. So x minus 2y equals negative 4. Y equals 1/2 x plus 2. So I'm looking at these and I'm thinking they're not really set up for elimination. Okay, Nathaniel, watch this. They kind of look like they're ready for what method? Substitution. So what could I do now that y is already solved for? What could I do with that whole 1/2 x plus 2? Put it where? In the other equation for y. Because it's just screaming for substitution. So watch. X minus 2y equals negative 4. What is y? 1/2 x plus 2. Go ahead and do a little bit of math that you know how to do. What is negative times a positive? And what's half of 2? 1. And then I have my x. And then I have to do this negative 2 times this positive 2. And I go to combine my x's and I have one x. And I need to take away an x. So what happens with those? They completely cancel out. And what am I left with on the left? And what am I left with on the right? Hey, that's not false. That's true. Negative 4 does equal negative 4. So guess what? I have a true statement. So what does true statement mean? And what has it meant in the past? It means the same thing. Instead of these two lines meeting nowhere, they meet everywhere. They are the same line. They are one line on top of the other line. So this means infinitely many. This means if I were to graph these two, so I'm going to say this is true, which is going to tell me infinitely many, which means if I go to graph one line and then I go to graph the other line, I made it just a little bit longer so you can kind of see. Where do they meet? Everywhere. They meet here, they meet here, they meet here. And that's what infinitely many looks like. Okay, that was option 1. We solved it with a method. What's option 2? Solve them both for y. Hey, what does that mean? If they're parallel, they have the same slope but different y-intercepts. If they're the same line, we better expect what to happen? Same slope and same y-intercept, same everything. But guess what? This first one's already solved for, so we're good. We didn't even need to solve it for y. It was given, solved for y. Let's just solve this one for y. What should we get? What should we expect to get? That, because I just proved with a method that it's infinitely many. Let's just confirm with our form that it is infinitely many. So y is equal to, cancel those negatives, there's my 1/2 slope. Cancel those negatives, there's my +2. It's the same line, okay? And I confirmed that by canceling them out and seeing if it's true, and then finding the same slope, same y-intercept. Are you good with that? Okay, so now you've seen both special cases. No solution, parallel, they don't meet anywhere. The opposite of that is they're meeting everywhere because they're the same darn line. One is right on top of the other, okay? What if I gave you a problem, if I were to give you a test, and I said, hey, see this system right here? 5x plus 3y equals 6, and negative 5x minus 3y equals 3. Don't worry about solving it. Just tell me how many solutions there would be. How many solutions? You have 3 choices. There's either one solution and they meet at an actual point. There's either no solution because they are parallel, or there's a bunch of them. Actually, more than a bunch. Infinitely many. Same line. Those are your only 3 choices. Well, guess what? I already know how to identify these two. If the variables cancel, it's one of these two. If the variables don't, they're meeting. And they're only meeting in one place. That is the last 2 tests we've taken. It's the non-special cases. What happens when I go to do this? I get nothing over here, and I get 9 over here. Last I checked, 0 does not equal 9. Where do these lines meet? Nowhere. Because that is a false statement. They are parallel. This is no solution. If I were to solve both of these for y, I'd get 2 lines that have a same slope, but a what? Different y-intercept. Got it? That's because it's no solution. So if I were to give you a problem like this, and then this is it, we're done after this. 6x plus 3y equals 9. 2x plus 9y equals 27. How many solutions? 1, none, or infinitely many? Well, I don't want to do substitution. I just want to multiply by this by -3 real quick, because that's going to give me a -6 here. Let me just do that. Let me get -6 here, -27y here, and then that's going to give me a -81. Watch. As soon as these cancel, but the y's don't, I'm done, because I have all the information I need. If there is a variable left for me to solve for, there will be one solution. You can guarantee it. It is not a special case, because you only get special cases when the variables cancel. Are you with me? Okay? So you're going to have some practice problems today, and there are going to be some that you